Hey guys, welcome back. How's it going? So today we're gonna try to set up STM32 development environment on Linux system with Visual Studio Code, Cortex-Debug, and OpenOCD. So I already prepared a fresh installation of Zorin OS. So if you're not familiar with what Zorin OS is, Zorin OS is a Linux distribution based on Ubuntu. It uses a GNOME and XFCE desktop environment as default, just like the many versions of Ubuntu distributions. The desktop is heavily customized in order to help users transition from Windows and macOS easily. Software on Windows can be run with Wine and Play on Linux, allowing users to run compatible Windows software like Microsoft Office. Zorin OS creators maintain three free edition of operating system and a pro edition for purchase. So do check out their website at https://zorin.com. All right, so without further ado, let's get started. In Zorin OS, let's open terminal and type sudo apt-get update. So always with every Linux distribution, you have to update and upgrade to get the latest fixes, bug fixes, and package update from the repo. All right, next is sudo apt-get upgrade. Hit yes for that. So this is gonna take some time to do the upgrade. So I'm gonna fast forward the video and I'll be right back. All right, that's done. So we're gonna start installing the tools that we need. So type in sudo apt-get install git build essentials and then gcc arm none eab. So this is a compiler that we need for STM32, and then libtool, and then libusb dash 1.0 dash o libusb dash 1.0 dash o dash def, and then gdp multi-arch. Hit enter for that. Provide the password. Hit yes for that. And let's give it some time to collect all of those packages. So within Ubuntu 2004 or Zorin OS, there is also OpenOCD package. But seems like that OpenOCD package is too old, so we have to build it from source. And those some of those libtool and libusb are dependency for that. Okay, so I'm gonna reboot the system and I'll be right back. All right, we're back. So open a browser, and I'm gonna show you where we can download OpenOCD source code. So type in the browser github.com slash OpenOCD org slash OpenOCD, hit enter, and that's where the source code of OpenOCD on GitHub page, GitHub repo. Now go to the terminal and type in git clone https://github.com /openocd-org /openocd. And this will create a clone of that repository into your local drive, and we're gonna build from there. Let's give it some time. All right, that's done. Let's change into that directory. So cd OpenOCD and type in bootstrap. So this command is going to collect all dependency it needs to build OpenOCD. All right, now let's do with the configuration. So slash configure. I want to install it under the user local, and then I enable FTDI, enable also ST-Link, and enable JLink. So if you have JLink, you can also use with OpenOCD. And the STM32 discovery that I have, it has built-in ST-Link. So we're going to use that. And if you have a generic FTDI board like FTDI 232 or FTDI 2232, then you can also use OpenOCD. So we're gonna make some videos on that as well. So make sure that you subscribe and like the video if you enjoy watching it. Okay, that's done. Let's type make. So this is gonna take some time, so I'll be right back. I'm gonna fast forward the video. All right, that's done. Now we can install it. So type in sudo make install and provide the password. And installation is done. Now type in OpenOCD-V to see if it's there. Yes, version 0.12. You want to see the location, type which OpenOCD. And yes, that was the prefix that we configure, /user/local. All right, so next, we're going to download Visual Studio Code. So type in the browser Visual Studio Code and hit download. So I'm on Zorin or Ubuntu base, so download the Debian package. All right, that's done. Let's take a look inside the folder where it gets downloaded. So it's under Home, Downloads. So you could actually double click this Debian package. It's gonna install it for you. But I'm gonna show you the way I do it on the terminal. Why? Why, you ask? If you do it on the terminal, you can, if there is an error message, you can capture it in the terminal. So I changed that directory. So you can see it's there. So the command is sudo dpkg this I and the Debian package. All right, Visual Studio installation is done. So I'm gonna close this because we're not gonna use the terminal anymore. We don't need a browser as well. Let's open Visual Studio Code. And that's where Studio Code is. So what we're gonna do, when this is the first time you install Visual Studio Code, you're gonna go to the extension and we're gonna install the extension that we need. First is C and C++. So that is a C and C++ extension by Microsoft. Hit install. You might want to install the extension pack as well. So hit that install. Next, we're gonna try to find Cortex-Debug extension. So the first one, hit install. Make sure it's by Maris 25. And then, sorry. And then make file, tools. This is also by Microsoft. Hit install. And then Git graph. So if you work a lot with the version control, Git version control, Git graph is kind of the graphical user interface of it. So it's really useful. I love that. Next is serial monitor. So if we use a lot of printf or UART messages, then this is like a good extension that you might want to have. Let's clean that and take a look at the progress here. So we got everything, they're all installing. So yeah, I'll be right back. I'm gonna fast forward this. All right, so extension installation is done. Now we're gonna grab the libopencm3 examples. So with the STM32, there is an open source libopencm3 instead of using the STM Hall as alternative. And they also provide examples. And this is the GitHub repository of the examples. So remember that link. That's where we can clone their examples. So let's open terminal and type git clone https://github.com/libopencm3/libopencm3-examples. All right, cloning is done. Now let's change into that directory and type in Git Sub Module init. Next command is Git Sub Module update. But before I hit enter, I'm going to show you why we need to execute Git Sub Module command. So if you look into the folder, this is where we clone the libopencm3 examples. And if you go into the examples, you can see that they're all populated in there. But if you go to libopencm3, it's still empty, and this is actually the library that we need, right? So they have a separate repo. So when you type in Git Sub Module update, Git Sub Module init and update, it's gonna populate for you, as you can see here in this folder, this file manager. All right, it's done. Now I'm gonna close that. We don't need a terminal, we don't need a browser. So let's focus on Visual Studio Code and open that folder that we just cloned. So go into libopencm3 and hit open. And I'm gonna put a check mark on this. Yes, I trust the authors. And as you can see here, this is the exact same folder structure as you can see in the file manager. So I have STM32F4 discovery. So I'm gonna go with example STM32 F4 STM32 F4 discovery, and I'm gonna choose the simplest one, which is mini blink. Let's open the terminal. So there is an integrated terminal within Visual Studio Code, which is cool. Gonna extend this a little bit. And now you type make in here. And if this is the first time you build with libopencm3, it's gonna build all the libraries for different MCUs, different architecture for the first time. So give it some time. I'm gonna fast forward this video and be right back. Right, there's an error message there, but if you type make again, sorry, make, that's actually gonna build the executable for you. That's the elf and the map. So the error is not actually for STM32F4, it's just for PAT55XX. All right, so next, we're gonna go to run and debug and create a launch JSON file and hit that add configurations, Cortex-Debug's OpenOCD. And here, you're gonna have to point to where the executable is. So that will be examples, STM32, F4, STM32, F4 discovery, mini blink, and slash mini blink dot. All right, there you go. And then next, go to the config files. You're gonna add this, you're gonna point this to the location of the interface and also the target. So that will be in user local share OpenOCD / scripts / interface / ST-link. We got ST-link on board on STM32F4. And the target is USR local share OpenOCD / scripts / target / STM32F4x.cfg, and save that. And now we're gonna create a new file called as settings.json. I'm gonna add two configuration here for Cortex-Debug. The first one is Cortex-Debug dot GDB path. Where's that? There you go, GDB path, and point it to /USR /bin /GDB multi-arch or multi-arch. And then the second configuration is Cortex-Debug dot OpenOCD path, and you need to point that to USR local bin /OpenOCD, and save that. And let's double check what we had written here. Looks good. Looks good to me. So let's go ahead to debug this. That's the debug configuration. And let's hit that small triangle button next to it. And we should be good to go. Well, not quite. So let's see what the error message is. Let's go to terminal and see what that is. Okay, so seems like this is an access permission. You know, in Linux system, you always you need to get access permission to access a USB. So that's what happened. And yeah, I'm not sure this is a UDEF thing. So I'm gonna pause the video. I'm gonna try to search for it on Google and be right back. All right, so I'm back. So what I did was I copied this error and then I open a browser and just search for it. This is a typo fix. And I click the second link, the sub link in there. And it gives me this thread. So you can go and read the thread. But the most important part is there is a user manual that provides you with a step-by-step on how to do it. So we're not gonna do all the steps here. Remember what I said, that it was permission issue. So what we want to do is actually to find the steps. So let's search for the access. There you go. The enable access to USB device. So there is a step 1, blah, blah. You can read this. So if you have an ST-Link and J-Link, you might want to do this to set up the UDEF rule. There's step number 2, step number 3. And well, this is actually the step number 4 that we need. So we're gonna need to add our user into plug dev group, and that's how to get the permission. So I copy and paste that, execute here, and let's go back to Visual Studio Code, hit that triangle button, and there you have it. Now you can flash and debug STM32 with the Cortex-Debug extension on Visual Studio Code. So you can hit play, hit run, pause it, step over it, step in, step out, and of course you can also stop it. And that's how easy it is. So yeah. So today we have set up STM32 development environment under Linux system. Let me know if you have any comment or questions in the comment section down below. And yeah, so please subscribe and like the video if you enjoy watching. Check also my Patreon page and show your support. And other than that, see you in the next video, and happy coding.